I'll just cut the video and start here. Welcome to Algebra 1. Here's our key. Yep, so decreasing means you're going down, so the answers were between 2 and 3. And I'm going fast because we've been working on this for like 5 minutes now. 5 and 8, and between 13 and 15. 13, 13, and 15. That was a bad 3.
On the benchmark, are they going to want us to write every possibility down?
It's going to be multiple choice. I just didn't have the time to make it multiple choice for you guys. Number 2, rock change elevation between 0 and 1 second. So between 0 and 1, it went from 80 or from 100 to 86. So you're really doing 86 minus 100. So if I'm showing my work, I'm saying this is 86 minus 100. You guys can shout out, it's negative 14. Between 1 and 2 seconds, it's going from, so you're going to do 38 minus 86 and negative 48, thank you. And technically all these should be in feet if I am correct. Negative 80, and then between 2 and 2.3 seconds. Notice that this number right here by itself isn't the same as these. This was 1, then 0.3, so it is kind of a weird number. So even if this one matches, it doesn't really mean that much unless we convert it to a slope, but that doesn't matter. And this one is going to be minus 38 feet. And based on these answers, are these data linear? The answer is no. No, and you can say because the differences are not the same.
Could you say because it's not going down at a constant rate?
Because it's not going down at a constant rate, yeah, that's another great way to explain it. All right, and I think we're all good on number 2. Let's go on to number 3. All right, so it decreases quickly at first. So which of these is decreasing at first? Only one of them.
C.
Why and Emma have it? It is only that one. And then you can see that it still matches because it's decreasing quickly at first. So it's going down steeply at first, and then it decreases over time. The rate decreases. The rate of decrease decreases, which means it gets flatter and flatter. If the increase decreases, that means it's increasing at a decreasing rate. It's kind of hard to say in words, but it's getting more and more flat over time. So it is C. All right, number 4, subtract these things. So the correct way to do this is I need to distribute this negative into each of these 3 terms. So my new equation after distributing this negative is, and whenever I distribute the negative, it turns into a positive because I've used up the negative symbol. So my new equation is 2x squared minus 3x minus 10. That didn't change. The left-hand side, it's still the same. But now I'm going to say, I'm going to plus all of this stuff, or, yeah, sure, I'll write it that way. Plus all of this stuff, which is minus 4x squared minus 6x plus 1. Again, I'm switching the signs here. Kira.
I did that problem and I did it wrong, so I have to redo it.
Yes, please. So again, I'm distributing the negative, and then from there I'm adding like terms. The definition of a like term, I forget, have we talked about like terms in here yet? I don't think we have. Like terms, this is an informal definition. There's technically 2 parts of like terms, but for this one, for the benchmark, you only need the first part, which is same exponent. So look at and if you don't like the word exponent, you can say the word power. If they have the same power, or if they don't even have a variable, then that's a like term. So this is a power of 2. Do you see any other powers of 2s? Where are they? Where are they? Ah, there it is. So now I just add the coefficients. 2 and negative 4. What's 2 minus 4? Shout it out.
Negative 2.
Yeah, so it's negative 2, and I leave the x squared. So negative 2x squared. And if anyone is confused by this because they're like, wait, this is going too fast, it's like, I spent an entire lesson just teaching you how to do this. So that's why I apologize. Like, I am going kind of fast. Let's look for the same power. So these are technically a power of 1 and a power of 1, or just x terms. So any x terms I have. Well, I can underline them to make them stand out. I have this negative 3x and this negative 6x. Okay, so those are like terms because they have the same power of 1. Let's do -3 minus 6 and shout that out. It is
Negative
and -9, and then I just change, or I keep it the same, still x. The most common error when it comes to these is like saying, oh, if I'm subtracting 2 and 2, I get 0 or something, or maybe I add them. 2 and 2 makes 4. No, you leave the power. The power does not change. The power does not change at all. And then finally, I can circle these terms. I have a -10 and a +1. Those are like terms. What's -10 plus 1?
negative
Negative
9.
9.
And there's the answer.
Wait, so this is. Okay. I'll take it.
All right. Number 5. Number 5 is multiplying. So there's 2 ways that I teach how to multiply this. You can either FOIL this. How many of you have heard of foiling? How many of you have heard of a tabular method, also known as an area model? Nothing like that. I'll teach you the area model. It's the easiest way to do it. So go ahead and make a square down here that has, so you make a square first of all, and then I divide it into 2 pieces like so. The sides of the square are going to be these terms. So for example, I'm just going to randomly choose the top of the square. I could have chosen left. I'm going to choose the top of the square and I'm going to say, the top of the square is 3x plus 5. So 3x is the first term, plus 5 is the second term. Guess what the left side is going to be?
2x minus 3.
It is going to be 2x minus 3.
Oh, this is like the butterfly. I
Oh.
think we learned.
Okay, so butterfly method possibly. And then you have to multiply each of these. So I'm saying I'm going to multiply this whole column by 3x, this whole row by 2x. So this cell right here, this box, is going to be 3x times 2x for this box. So 3 times 2 is 6, and then x times x, I'm really adding the powers. So this was a power of 1, and this was a power of 1. 1 plus 1 is x to the power of 2. So this is 6x squared. Technically, and I'm going to write this in a different color because you don't need to write this down.
Plus or multiply?
You're always multiplying because it says, yeah, multiply here. Technically, this is x to the power of 0. X to the power of 0, anything to the power of 0 is just 1, and then 5 times 1 is just 5. So I'm going to keep that x to the power of 0 because it kind of helps you multiply. So 5x to the power of 0 times 2x to the power of 1, well, 2 times 5, shout it out, is 10. And then I'm going to add the exponents. 1 plus 0 is 1, so it's x to the power of 1. Or, and you don't have to write x to the power of 1, you can just write x.
But
Right?
there was no x on that 5, and if they don't both have an x, then you can't add them.
So that is a true statement, but in general, if I'm multiplying a times b times c, just a random problem, the answer here is just you squish them together, right? A, B, C. So if I had 2 times x, which is 2x, right? This thing is 2x. 2 times x times 5, which is exactly what this is saying, 2x 5. 2 times x times 5 is you multiply these all together. I squish them together, which is 2x 5, and 5 and 2 make 10, so this is 10x, which is the same answer that we just got right here. So there's, like, I can show you 4 different ways of thinking about multiplication. This is the easiest one that I know of. If you like a different one, by all means use that one. Let's try this one. I'm now going to multiply 3x to the power of 1 times -3. And again, you can think of this one as, okay, there's really an x to the power of 0, or you can just think of this as, oh, just squish them together. Anyone want to take a shot at it? You can just, yeah, Charles?
-9 to the power of 1?
-9x to the power of 1, yeah. Or just -9x. Perfect. And this last one is super, super easy. Just 5 times -3. Wyatt?
Negative 15.
-15. We've done the hard multiplication. The next step is to combine the like terms. If you've done this correctly, it should almost always be these diagonals right here. Those are the like terms. Esha,
So why didn't we put an x after -15?
you can put an x to the power of 0 if you want, but x to the power of 0 is just the same thing as 1, so it's just -15. The original problem, again, was just, if I come back over here, the original problem was 5 times -3. Came from those last 2 numbers, right? I know I feel terrible because this is not the best explanation. It's not my best moment in teaching, but sorry, we have to go fast. So this is almost the answer. I need to now add up all of the area. So how many x squareds do you see?
1.
Two.
I just see 1x squared, because these are both x to the power of 1, x to the power of 1. So there's only 1x squared, so I can't combine that with anything else. There's no like terms, so I just have to list it again. Super easy. I can't do anything, so just list it. Do you see any other constants without any powers or without any variables? No, so I just list that one again. I'm going to list it over here to the right-hand side, giving a gap right here, minus 15. However, I can combine negative 9x and positive 10. Anyone combine that for me? Jade? 1x. Yeah, there it is. And that's a positive 1x, so there's your final answer. 6x squared plus 1x minus 15. And you can rewrite that, again, you don't have to say 1x. You could have just said this 1x right here is the same thing as just x. Yes.
Does it matter what order you write it?
Mathematically speaking, no. But there is something called standard form, which, go away, I don't. There is something called standard form where you write them in the biggest powers. This was the power of 2, this was the power of 1, this was the power hidden 0. You should write it in descending powers, but it's still mathematically correct. It is just more professional to write it in standard form. What's going on here? All right, so there's our final answer. Let's go on to number 6. You don't need a ruler, although you should be drawing as straight lines as possible. Here we go. We need to match a line with each sentence. Draw a line to match each sentence with the equation that meets the given condition. So I'm drawing lines like this, right? Things that connect each other. So the equation is true for x equals 2 and x equals negative 2. That is just saying the answer is x equals 2 and x equals negative 2. The way that you solve these is plug them in. They should make it so that the left side equals the right side. So the general way to make this side, the general way to solve this problem is making sure that the left has the same number as the right. So an answer would be like, oh yeah, 2 equals 2. That means that is the true statement, right? We've talked about that before. So let's plug in 2. It should work for both 2 and negative 2. If I plug in 2 here, this is going to be 2 squared, shout out. 2 times 2 is 4. And then 2 times negative 5 is negative 10. 4 minus 10, shout that one out is? Okay, so we have the left-hand side is negative 6. The right-hand side is 0. Is that a true statement? No. Okay, well that one doesn't obviously match with this one. Let's try, because I'm kind of speeding this one up, you'd go through each and every one of them. Let's try plugging it into this one. 2 to the power of 2 is? 4. Okay, so the left-hand side is 4. Oh, the right-hand side is 4. So it seems to work for that one. We have to check as well the negative 2. Let's plug in negative 2. Negative 2 squared is the same thing as negative 2 times negative 2. What's negative 2 times negative 2? 4. And then the right-hand side is also 4. Okay, so this one seems to match up with this equation. So that's the line that I draw. And again, for this class, normally I don't like yelling out, but let's just yell out because it'll go nice and fast. Why are you downloading one password? Stop. Remind me later. I'm teaching a lesson. All right, so let's try another one. Let's plug in 0 and see if it works for any of these, right? Let's plug in 0. 0 squared is 0. 0 times 5 is 0. Does 0 equal 0?
Yeah.
That seems to work. Let's check it one more time. Let's plug in 5. 5 squared, shout it out, is? Careful. 5 times 5? There you go, 25. And what about negative 5 times 5 is?
Negative 25.
Negative 25. Oh, on the left-hand side, I therefore have?
0.
Yeah, 25 minus 25, which is 0.
Yeah, 0.
0 equals 0, which means that one matched up there. Today is Mr. Godoy's birthday? What?
Really?
I just got a notification on my phone from Facebook. All right, so the equation is true for all values of x, which means I can plug in any single value. There's a shortcut for this, and you've already learned it. If the left side is exactly equal to the right side, the answer is all real solutions. Does anything look exactly the same on the left and the right? Which one is it? Is it 1, 2, or 3, 4? 2. Yeah, so just match this one up with 2. And by process of elimination, this one goes there, and there's our final answer. And this one makes sense too, right? The equation is false for all real values. Check this one out. Well, if I subtract 7x on both sides, 7x, 7x, 4 is equal to negative 4. That can never happen. That's like saying 2 is equal to 1. So that's why that one is never true. And we've talked about that one before, so I'm not going to explain it too in depth. Exactly, yeah. All right. If you guys have questions, you can hold up your hand. I can hopefully answer it to the best of my ability, nice and quick. And we're on to number 7. Again, another matching question. And this one is hard because they have these weird things, commutative property of addition. So commutative just means switch. Let me show you a commutative property of addition. Are you guys ready? A plus B is the same thing as B plus A. Did you know that? If you do 1 plus 2, it's the same thing as 2 plus 1. Your mind just exploded. You never thought about that before. That's called the commutative property of addition. Subtraction property of equality just means I can subtract the same thing on both sides of the equation. So subtraction property of equality, that's the same thing as saying minus on this side, minus on this side. It balances the equation. Multiplicative property or multiplication property of equality just means I can multiply by 2 on this side, multiply by 2 on this side. It still is the same equation. Addition property of equality means I can add 3 on this side, add 3 on that side of the equal sign, I should mention. These are always on each side of the equal sign, and you're still going to balance it.
Oh, this is like, we learned about this earlier this year, like when they're doing like with the scales.
Yeah, this is the scales lesson. These are the formal names that, I don't know, in my opinion as a teacher, you don't need to know the formal names because why know the name of it if you can just do it? But maybe other teachers disagree with me, I don't know. Multiplication property of equality, again, that's the same thing up here. Multiplication property of equality, that's the same thing as like times 1/2. No, it's usually times an integer, like times -2 and times -2 on both sides. All right, so let's match these. So here's our original equation. 3x plus 5 equals 2 minus 8x. And you can see that it's very similar in each of these. I have a 3x plus 5, a 2 minus 8x. What is the difference in that first one, though? What did they do to it? You guys can just shout it out for this whole benchmark.
It's like a negative on the left side, a -2, and then it's a +2, and it's on the other side. And then on the left side, it's a +5, and on the right side, it's a -8.
Yeah, so the 2 minus 8x, 2 minus 8x, that still matches up. The 3x plus 5, the 3x plus 5 still matches up. And I agree. It was multiplied by a -2/9 and a +2/9. So if I'm multiplying by 2/9, which property do you think we're going to be using? You guys can shout this one out.
The multiplication property of equality.
Multiplication. And do they use it correctly? No, why? Just shout it out again,
Because
sorry.
there's one negative and there's one positive.
Exactly. So somehow they misused the multiplication property of equality. Which one says that? Oh, the third one. Okay, yeah. This one, misusing the multiplication property of equality. So match that one with that one. Nice. All right. Let's take a look at this one. 5 plus 3x. Oh, that looks very similar to 3x plus 5. 8x minus 2 is 2 minus 8x. Which one do you think they're using? Again, you guys are so trained. I love it, and I hate to break this habit.
Misuse of commutative property of addition.
There it is, yeah. It's misusing it because it's only the property of addition. There's no such thing as the property of subtraction. There's no commutative property of subtraction. That's why it's being misused. And it's the same thing. I can explain this really quickly. Check this out. Ready? Oops. If I have 2 minus 1, is that the same thing as 1 minus 2? No, one of them is 1, one of them is -1. So there's no commutative property of subtraction. Moving on, 11x plus 5. Oh, what did they probably do to both sides? There's no more x on the right-hand side. Anyone see what they did? Again, just shout this one out. No, careful. They moved that 8x over by doing something to both sides. What did they do? They added 8x. If I add 8x and I add 8x, 8x plus 3x is 11x. So what did they do to both sides? Did they add, subtract? What are they doing?
They just added data.
Addition property of equality.
Addition, yeah. So where's that? Right here. Addition property of equality, and they use it correctly, right? That's still the correct equation. Now the next step would be to subtract 5 on both sides and solve. But there it is. They use the addition property of equality correctly. So let's match that one up correctly. Right there. I don't know why that is blue. And let's go down here. 6x plus 10 on the left-hand side. Check out the difference. What happened there? 4 minus 16x, 4 minus 16. Oh, they times 2 on both sides. Did they do it correctly?
Yeah.
Yeah, so the answer is yes, and it's multiplication property of equality. So it's that bottom one. And by process of elimination, we know this one is right up here. And this one was misusing the subtraction property of equality. Do you guys see why? What do they subtract from the left-hand side? Minus 5 minus what is 1?
4.
Yeah, so they subtracted 4 on this side, which means they should have subtracted 4 on the right side. 2 minus 4 is negative
2.
Negative 2, yeah. And they, well, they don't, that's like not even the same thing. Yeah, that's weird. Yeah, I think that's just a typo from Mr. Sandel. I meant to write negative 3 and I wrote negative 3x. That's my bad.
You made this whole thing.
I made this whole thing, yes. And I based it off of the benchmark and I just switched the numbers around. And yeah, I finished this at 2 in the morning, so it's a little bit off. It's a little bit wonky. All right, so, okay, this question took me at least 10 minutes to make. It took me forever to make this question because I need to make the number come out nice. And if it doesn't come out nice, I blame someone else. That's not me. All right, so let's try it. Here is the giant hint. You're going to have a fraction question with an inequality on your benchmark, just like this, with switched numbers, and it does come out nice. By coming out nice, it's the answer's like, I don't know, 7 over 2 or something like that. I think of that as coming out nice. So the best way to do this problem is to get rid of fractions because fractions are hard. How do you do that, Mr. Sandel? Well, what could I multiply every single 4 of these numbers by to get rid of the fractions? Shout it out if you know it.
3.
3 would almost work, but 3 on this one would not work.
6.
Even bigger. 6. Yeah. Yeah, sorry, we can shout out for this lesson. So let's multiply every single one of these by 6. So I now have negative 6 over 3x plus 5 times 6 is 30. It's less than or equal to 8 times 6. Oh, 6 times 8 is 48. And don't forget your x. And if I multiply 6, again, you can cross cancel. You can.
I think it's just plus 5.
Oh, that's
30, yeah. So 5 times 6 is 30. And I can say 5 times 6 is 30, so plus 30 over 6. And then I can reduce this fraction again. So I can say, okay, I know what negative 6 divided by 3 is. Negative 6 divided by 3, you can shout this one out, is...
5.
Negative 2.
Careful.
Negative 2.
You're good.
Wait.
It's okay, it's okay. Okay, plus 30, less than or equal to. This is a safe environment. Mistakes are a good thing. She just learned. 48x. And what about 30 divided by 6? 5. Look, we've gotten rid of the fractions. Woo! All right, now we actually have to do like our normal math. And we've done problems like this in our previous unit. So let's choose a side for all the x's to be on. Do we want the right side or the left side?
Right side.
No, you want the side.
Right side because
Right
then
side,
it'll be
actually.
positive.
Yeah, let's see. Okay, so let's go ahead and add 2x to both sides then. If I add 2x to both sides, that means that my variable is on my right side. So my new equation, I'm going to come back up here because I ran out of room, is I still have that 30 on the left-hand side. I still have the less, oh, that's an equal to sign. I still have the less than or equal to sign. I now have 50x, and I have plus 5. Next step is to shout it out.
Subtract 5.
Again, yeah, we're trying to move this constant term to the left-hand side. I know I'm going kind of fast, and I'm apologizing so much this lesson. I don't like going fast because it leaves some people behind, some people with not the understanding that they should be having. But yeah, 30 minus 5 on the left-hand side is 25. I can write a little bit neater, Mr. Sindel. Less than or equal to, and I still have the 50x left on the right-hand side, remaining on the right-hand side. And then, finally, my last step is to do what to both sides? Shout it out.
Divide by 50.
There it is. And can anyone reduce 25 over 50? You guys are so good at raising your hands. I hate to break this
Also,
habit.
1/2.
Hey.
No, 1/2.
Yeah, I can divide the top and bottom by 25. So if I divide 25 by 25, I get 1. Divide 50 by 25, I get 2. So 1/2 is less than or equal to x. There is our final answer for that first part.
What does it mean when it says capture the answer on the number line?
I will show you. Yeah, so on a number line, so you need to draw a number line. Roop. That is a horrible number line. There it is. So, a less than or equal to, is that a filled point or is it an open point?
closed.
Or it's filled, closed. Yeah, it has many names. So make a filled or closed point a point that is all the way not hollow right there. Is it going to be going left or is it going to be going right? If it says, oh, this one is going to be tricky. This one is tricky. I just realized that.
Wait.
Got it.
Wait.
Okay, let me give you guys this hint. If I want to change this form, I can change this both ways, to the left and to the right. I want the x on the left-hand side. 1/2 is still on the right-hand side. My question is, what sign do I write here if x is on the left-hand side instead of the right-hand side? Is it a less than or is it a greater than? You flip it, so it's going to be a,
Less than.
it was a less than, so it's now going to be a greater than. Exactly, yeah. So if x is greater than 1/2, if your variable is always on the left-hand side, then it's pretty easy to tell what's happening. If it's x is greater than 1/2, well, here's 1/2. Label it 1/2. If it's greater than 1/2, then 1/2 or x must be on the right or the left.
Is it negative
Right.
1/2?
It should be positive 1/2, I think.
Oh yeah, because we just. Never mind.
No, you're good. You're good. I like those questions. You're always questioning whether it's the right answer or not. Yeah, so it goes to the right because it's always greater than. You can still get the same graph from here. You just have to be careful. You have to read it backwards. So I like rewriting it where the variable's on the left-hand side because it makes it much clearer on what the answer is. So there's the graph. It's a solid point and all the answers are to the right. So far, so good?
Yeah.
All right, and we get out of here in 5 minutes. Let's see how far we can get. All right, so we have these two inequalities. X is greater than or equal to 10. X is less than 2. I need to graph them on another number line. Go ahead and make your number line. Whoop. Sound effects help. All right, so x is greater than or equal to 10. Is that a filled solid point or is it an open point?
Which one? Solid.
For the 10.
Filled.
Filled. And 10 is bigger than 2, so it's going to be on the right-hand side. Here is 10. Is it going to be to the left or to the right of 10?
To the right.
To the right of 10. Perfect. All right. What about x is less than negative 2? Is that open or filled?
Open.
Open. All right. Open at 2. I can label that 2. And am I going to the right or left?
Left.
Left. Okay. So there's the graph. Oh, this keyword or. Is that allowed? Is the answer no solutions or is that the solution? Remember the difference between or and.
That is the solution.
That is the solution.
Or yeah.
And is the word that means only where they overlap. Only overlap. If this question was changed to an and right here, whoa, what just happened? If this question was changed to an and right here, the answer would be no solutions because there's no overlap. Or means anything.
It can be anything.
Anything as long as you have a line. I like the anything is too informal. I'm going to change it to at least one. All right. How many solutions are there to this system of inequalities? There is a lot. There's an infinite number of answers.
There's an unknown number of solutions.
Unknown?
Wouldn't it be like?
It is infinite, though. We know.
Wouldn't it be 2 or 10?
So technically, technically 0 is an answer. Technically, negative 10 is an answer. Technically, negative 100 is an answer. Negative 1,000 is an answer. Negative 2,000, negative 2,000.00987 is an answer. There are an infinite number of answers. And if you're thinking about it correctly, check out this interval. This interval between 0 and 1. What if this was your answer? Only this. Nothing over here, nothing over here, just between 0 and 1. How many answers are between 0 and 1?
1.
An infinite number! Because I can do a half, I can do a third, I can do 2/7, I can do 3/11, I can do 0.009765432. That's an answer. There are an infinite number of answers. The answer is always infinite, as long as you have an answer.
Pi, but it's
I meant. It says
Pi is an answer. Well, yeah. Pi divided by
pi, but it's negative.
pi divided by 4 would work.
No, it's negative, and then you put pi.
Anyway, yeah, so there are an infinite number of answers. What is the smallest value of x in the solution set? Well, this one, the smallest I can go is, I guess, negative infinity. I'm not sure what it's asking there. And explain your response. The solution set goes forever to the right, or forever to the left.
Mr. Sindel,
Yes.
when left equals right, left equals right, what does that mean?
That means that it is a true solution.
Can I ask a question that's off topic?
You may, because we are done. All right, so number 10, the solution of equations to this thing. So if this is equal to 0, then either this, or this has to be 0 because those are the three things that are being multiplied together. So you just assume all of them are set equal to 0. So you set each of them individually equal to 0. So x equals to 0, that's that one equal to 0. X minus 7 is equal to 0, that one is that one. And then x plus 1 is equal to 0. X plus 1 is equal to 0. Then I solve. So I'm going to add 7 on both sides for this one. I'm going to plus 7, and I get x is equal to 7. Subtract 1, and x is equal to -1. So our three answers are -1, 7, and 0. Those are the solutions to that equation. Number 11, which values are not permissible? Things that are not permissible, this is a swear word. You can't say this out loud. Are you ready? 1 divided by 0. Oh, okay, you can't divide by zeros. Whenever you do that, that's basically a swear word math. You can never do that. So what values will make this thing something divided by 0? Well, if this x equals 0 or this x plus 3 equals 0, then that will be not permissible. So again, I set just the bottom, not the top. I don't care if the top is 0, but the bottom can never be 0. So x equals 0 is something that's bad. X plus 3 equals 0, something that's bad. And again, I can subtract 3 on both sides, and x is equal to -3. So these are the two values that will make this a swear word, that will make it not permissible. So don't use 0 or -3. Those are the answers. Number 12, we have to graph these things really quick. So the way to do this first one, I think, if I just subtract x on both sides, subtract x, then I get the equation y is equal to -x plus 4. That means my slope is -1. Slope is -1. Which of these has a slope of -1? Just this one. So this is the x plus y is equal to 4 answer. And yeah, the y-intercept is 4, so that makes sense. Let's try this one. This is in standard form. So standard form, again, I set x equal to 0. So my y-intercept is -3. Y is equal to -3 for this one. And then if I set y to 0, then that means x is equal to 2. Okay, so the x-intercept is 2. X-intercept is 2. Ooh, that has 2 and 2. The y-intercept is -3. There's the y-intercept of -3. That one's not it. So I come back here and I say, okay, that one is the answer. So this is going to be 3x minus 2y is equal to 6. That matches up here. I guess I should be drawing a line, but it was kind of messy. 3x minus 1, that means my y-intercept is -1. This one has a y-intercept of -1. It has a slope of 3. That makes sense too because I go right 1, up 1, 2, 3 to make my triangle. Up 3, right 1. This indeed has a slope of 3, so this one is the y equals 3x minus 1. This one, I'm going to switch this around a little bit. I'm going to subtract 2, so I get -2, -2, and I get x minus 2 is equal to y, and I just flip these around and say y is equal to x minus 2, which means my slope is 1, my y-intercept is -2. My slope is 1, y-intercept of -2. Obviously, it's this one. It's going to be y. I was about to write y equals x minus 2, but it's actually x is equal to 2 plus y. That one matches there. And finally, this one is a little bit challenging. So Em and Charles, again, I changed the names to you guys. They're playing each other in chess. Charles has won 5 out of 16 games, so he's a little bit losing, but we want to see how many games will he have to win in a row to get 50%. And this one, you can either do it with an equation, but let me show you the long way. The long way of doing it is as follows. So if I win another one, I have 5/16. I'm trying to get something that simplifies to 1/2. So if I add 1 plus 1 plus 1, that would be, because you won a game, but you're also adding on to the total number of games, that would be 6 out of 17. And then I add on again, so that would be 7 out of 18. Add on again, 8 out of 19. Still not halfway, because this times 2 should be the bottom number. We're almost there. You keep having going 9 out of 20, 10 out of 21, and finally 11 out of 22. Because 11 times 2 is 22, which means this fraction right here, I can circle this one, that one reduces to 1/2, which is 50%. I think that's probably the easiest way of doing it. I don't want to teach you guys anything new to find percentages, but you just keep adding on the top and the bottom, and it took 1, 2, 3, 4, 5, 6 games. So the answer here was 6 games. All right, and that concludes this video. Thank you for watching, especially these last few problems that we had to do outside of class. The benchmark is tomorrow. You guys are going to kill it. You're going to do it amazing. We're going to beat Colville. We'll see how we do. Yeah.